Day 624 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3047. Find the largest area of a square inside two rectangles. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There exist n rectangles in the 2D plane with edges parallel to the x and y axis. You are given 2D integer arrays bottom left and top right, where bottom left of I is equal to AI, BI, and top right of I is equal to CI, DI, represents the bottom left and top right coordinates of the ith rectangle respectively. You need to find the maximum area of a square that can fit inside the intersecting regions of at least two rectangles. Return 0 if such a square does not exist. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input bottom left equals a 2D array of integers which represent the coordinates. First coordinate 1, 1, second coordinate 2, 2, third coordinate is 3, 1. Then the top right is also a 2D array of integers that represents coordinates. First coordinate 3, 3, second coordinate 4, 4, and the third coordinate 6, 6. The output is 1. Now, before we get into the explanation, let's just go over what this actually means. So I'll copy and paste this over here like this. Boom. So this will be bottom left, and then we'll do top right over here. Let me see. Boom. Let's get the top right so you guys can see how the squares are made. Boom. So we can just get rid of this like this. Boom. So this is the bottom left corner. So this right here, this right here, and this right here are going to be our red square, right? So for the red square, the bottom left corner, we're right here. Top right corner is right here, 3, 3. So as you can see, this is the bottom left corner of the red square. This is the top right of this red square, right? So once again, bottom left, 1, 1, top right, 3, 3. Then for the blue square, this is the bottom left, 2, 2 corner. And then this right here is the top right corner, 4, 4. This is the blue square, right? This right here, boom, boom. That is this blue square from 2, 2 to 4, 4. And then for this green rectangle, we start at 3, 1, which is right here for the bottom left. And then the top right corner is 6, 6. So this is represents the green rectangle. So it's going by index. So the first index of top left and top right are going to make the red square. The second index of the second index of bottom left and top right are going to make the blue square. And then let's start over. The zero index 1, 1 is the zero index 1, 1 and 3, 3 is going to be this red square. The first index 2, 2 and 4, 4 is going to be this blue square. And then the second index 3, 1 is the bottom left corner of this green square, and 6, 6 is the top right corner of this green square. Boom. So now that we know that, let's look at the explanation. It says a square with side length 1 can fit inside either the intersecting regions of rectangles 0 and 1 or the intersecting regions of rectangles 1 and 2. So this right here is the intersecting region of 0 and 1, right? These two, 0 and 1. When I say 0 and 1, I mean these two squares right here. Boom. Index 0 and index 1. This is the overlapping region right here. Boom. So you can see that this has a length of 1. It goes from 2 to 3. And then it has a height of 1. It goes from 2 to 3 as well. 1 times 1 is 1. Or we could do the same thing at the intersecting region of rectangles 1 and 2, right? So right here, we could create a square right here, and then this would be a square, still have the length of side 1, height 1, and same if we created a square right here, this would also have a length of 1 and a width of 1. So either way, it's going to be 1 times 1. It says it can be shown that a square with a greater side length cannot fit into any intersecting region of the two rectangles. So that's why the output is 1. Because this intersecting square right here has a length of 1 and or a height of 1 times a width of 1, which gives us 1. And if we decided to do this square, we could also do a square here, which would also have a length of 1 or a height of 1 and a width of 1, or we could do a square here, which would also have a width of 1 and a height of 1. So either way we look at it, it's going to be 1 times 1, and the output is 1. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our input bottom left equals a 2-day array of integers representing the coordinates. First coordinate is 1, 1. Next coordinate is 1, 3. Next coordinate is 1, 5. For the top right, we also have 2D array of integers representing the coordinates. First one being 5, 5, then 5, 7, then 5, 9. Same principles apply, y'all. All right, so let's just bring this over here so we can see where our squares are lining up at. Boom. Then we'll do this right here. Boom. Boom. So once again, this is the first square. This is the second square. This is the third square. So our first square starts at 1, 1 in the bottom left, and the top right is 5, 5. So from here all the way to here, this is our whole first square right here. So notice that they're overlapping. That's why this is purple right here, because that's just the overlapping of this square, which brings us to our second square, which is 1, 3, and 5, 7. So our second square starts right here at 1, 3, and our top right is right here at 5, 7. So this is the second square right here. Boom. Once again, you can see it's shaded 2 different colors because this square overlaps, this third square overlaps the second square again. Third square starts at 1, 5 right here, bottom left, and then 5, 9 for top right. Boom. So this would be the third square right here. Boom. So as you can see, they all overlap each other. Now, if we wanted to, you can see the output is 4. So if we wanted to break this into squares, right, say of overlapping regions. So this is an overlapping region right here. So say we broke this up right here, boom, at 3. So it says a square with side length 2 can fit into either the intersecting regions of 0 and 1 or the intersecting region of rectangles 1 and 2. Hence, the maximum area is 2 times 2, which equals 4. It could be shown that a square with a greater side length cannot fit inside any intersecting region of rectangles. So, say we're looking at this intersecting region right here, or we could look at this intersecting region right here. Let's just say we just bring a line straight down the middle right here, right at 3. So say we have a line right here at 3. That means it goes from 1 right here to 3 right here. That has a width of 2, right? From 1 here to 3 here, that has a width of 2, right? Boom. And then it goes from 3 right here to 5 right here. Boom. So that also has a width of 2. So that would be our square. Boom. Or we could do it on this side. Either way, it's going to have a length of 2, right? We could go from 3 to 5. That would be 2, and then it'd still be 3 to 5 here. So either way, it's going to have a height of 2 and a width of 2. 2 times 2 is 4. Same with this square. It'd be the same, except this time we go 5 to 7, and it go 1 to 3. So either way, 1 to 3 is 2. 5 to 7 is 2. 2 times 2 is 4. Either way, our output is 4. Boom. Just in case that didn't make sense, let's take a look at example 3. So in example 3, once again, let's bring this over here. Boom, boom. It's the same principles apply though, y'all. But just in case we have some people that still haven't figured out what's going on here, we're going to go through it. So in example 3, we have our bottom left equals a 2D array of integers representing the coordinates. First coordinate 1, 1, second coordinate 2, 2, third coordinate 1, 2. Top right equals a 2D array of integers representing the coordinates. First coordinate 3, 3, next coordinate 4, 4, last coordinate 3, 4. Output is 1. Again, it says a square with side length 1 can fit inside the intersecting region of any two rectangles. Also, no larger square can be the maximum so the maximum area is 1. Note that the region can be formed by the intersection of more than two rectangles. So boom, this one is the same, right? It's similar. It's not the same, but it's similar to example 1, right? Where we have squares that can be created to have a length of 1, right? So it has to be an overlapping part. So this could be a square from 1 1 or 1 2 to 2 2 that has a length of 1. Then from 2 to 3 also has a length of 1. So this right here, this square right here, 1 times 1 would be 1. If we did this square right here from 2 2 to 2 3, that has a length of 1. And then from 2 to 3, from 2 to 3 right here, that has a length of 1. Once again, 1 times 1 is 1. So that would be 1 as well. Then finally, this square up top, boom, where it would go from 3 to 4, has a height of 1. Then it would go from 2 to 3 again, which has a width of 1. 1 times 1 would be 1. So the output is 1. Now, our last example, we could just look at this picture and we can understand why the output is 0, because none of these squares overlap, right? We're only worried about the overlapping squares. In this case, we could see just from this visual representation that they gave us why the output is 0, and that is because none of the squares overlap, y'all. So if none of the squares overlap, or none of the rectangles overlap, we just return 0. Explanation says no pair of rectangles intersect, hence the answer is 0. Boom, y'all. So now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get into it. Now, first thing we want to do is we want to get the number of rectangles. So we're going to say let n equal bottom left dot count. Boom. Then we're going to track the maximum square area found, so we can declare a variable called max area, and we'll set that equal to 0. Boom. Now we're going to compare every pair of rectangles. So we're going to say for I n 0 dot dot less than n, we're going to open up the brackets, and we're going to say for j and I plus 1 dot dot less than n, we're going to open up the brackets. Now we're going to compute the overlapping rectangle coordinates. So we're going to come right here, we'll say let left equal max, open up the parentheses, bottom left, square bracket I, come outside of that, square bracket 0. Boom, come outside of that, we're going to say comma, bottom left, sorry y'all, bottom left, square bracket J, comma, square bracket 0. Boom. Then we're going to come right here, declare a variable called right. So we're going to say let right equal min, open up the parentheses, top right, top right, square bracket I, square bracket 0, comma, top right, square bracket J, square bracket 0. Boom. Then we're going to get the bottom. We're going to say let bottom equal max, open up the parentheses, bottom left, comma square bracket 1, comma, bottom left, square bracket J, come outside of that, square bracket 1. Boom. Then we're going to come underneath that, and we are going to say let top equal min, open up the parentheses, top right, square bracket I, come outside of that, square bracket 1, come outside of that, comma, top right, square bracket J, come outside of that, square bracket 1. Boom. And if there is no overlap, skip this pair. So we'll come underneath this, and we'll say if left is greater than or equal to right, or two vertical lines, bottom is greater than or equal to top, we're going to open up the brackets, and we're going to say continue. Boom. then the largest square that fits inside the overlap is limited by the smaller dimension. So we'll come underneath this and we'll say let side equal min, open up the parentheses, right minus left, comma, top minus bottom. Boom. Then we're going to update the maximum square area by coming underneath this, and we're going to say max area equals max, open up the parentheses, max area, comma, side times side. Boom. And then we're going to return the largest square area found by coming right here, and we could just say return max area. Boom, y'all. That's all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 66 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.